I'm happy to like kind of actually work out the math here, the calculation. But we did the kind of heavy lifting on this problem. Is that good? Or if even one person wants to finish this off, we can. Yeah, let's do it. Okay. So hopefully, again, I would come back to this problem here with me. It's been since yesterday. So again, I think you had one like this in the homework tonight, last night too, maybe. Because you do some Pythagorean theorem ones too. I forget which ones were in which set. So this is helpful. We have this relationship. The Pythagorean theorem is always going to hold, no matter whether x, y, and z change. It's always going to be true that x squared plus y squared equals z squared. So that was the thing we took the derivative of, just to kind of recap. And we got this using implicit differentiation, all with respect to t. And remember yesterday, like the big theme here is like implicit differentiation, chain rule, right, is all right there, most important thing here. And then we said, given in the problem, were 4 of these things were just straight up given in the problem. The other thing, z was not given in the problem. The current value of z at the moment we freeze the picture was not given, but we said we can get it. So, and we did that, right? We used the Pythagorean theorem to compute it. Right there. So that's the recap. And now we really do have, for our equation that we were working with there, it looks complicated, but we really do have 5 of the things and only don't know 1 of the 6 things that are in that equation. So we'll just carefully plug them all in and solve for the unknown. So 2 times x is currently 0.8. dx dt is the thing we don't know. We'll just leave it there. Plus 2 times y, which is, where is it? 0.6. Thank you. dy dt is negative 60. By the way, I just for the sake of space, I didn't put units, but that's how I do like. Actually, I do like putting units. When you look at my answer key to this packet that you're doing for homework, you'll see I always put units everywhere. So, but we are running out of space. 1. And dz dt is 20. And then just solve for dx dt. By the way, feel free to divide everything by 2 if you haven't already done that, just to save yourself the trouble. We do without a calculator? I don't know. I think you could. It might come out pretty nicely. Let's see if I can do this without a calculator. Help me out here. 20, let's see, over there, minus, what's negative? Is that negative 3.6? Negative 36, rather. 36 and 20 is 46. 56, I mean. Divided by 8 is 7, but no, it'll be 70 instead because it's 0.8. How do we do? 70 miles an hour? Is that how? And who knows whether is that who knows whether that's against the law or not? I don't know. Maybe that's legal. Who knows? Probably not. Probably not. But we gotta know how illegal to write the ticket too, right? What's the speed limit in that neighborhood? Maybe it's 35, in which case that's like probably the person's about to get a point on their license. All right. Huh? Is that what it is? Why do you know that, Nicholas? Just theoretically, he's studied it. He doesn't. He's never actually. I'm not. Maybe I'll refrain from doing this. Well, I don't know. Maybe it'll be helpful. We just did a problem almost identical to this. I don't know. I feel bad, do we? So we'll come back to this if we need something more to do in our lives. Okay. I don't have too much to say, but why don't you give this one a try on your own, actually, if you haven't already started it. And then I'll come right behind you in just a minute and do it. But this is similar enough to one of our previous problems that I don't have a ton to say actually on this one. So let me let you go at it first, and then we'll come back together in about 3 minutes and see where you are. This is not in the packet? Okay, all right. This is cool. You just put it wherever you like then. I forget which ones are in the account. Yeah, I mean, I don't know if we had this discussion yet yesterday, right? So look at it yourself and see if. I'll do it. Yeah. This is not. Or is this exactly if you're something similar? You've already drawn a picture, I'm sure. Travels east. North. They were both here originally, huh? So this adds a little extra piece in there with the 6 minutes later. Like we don't know the side lengths, do we? Oh, maybe we do. Maybe we can figure it out, right? Maybe we can figure it out, can't we? So, what did we figure out for how far has A gone in the 6 minutes if A is going 40 miles per hour? Maybe think hard about that. 6 minutes is kind of convenient, though, isn't it? That's 1/10 of an hour. So 1/10 of an hour, 40 miles per hour. How far do you go? One car has gone 120 miles. One car has gone 2 hours. Has gone 50 miles.
The rate of distance change and the rate of distance change is the same for all the time. Okay, that makes a lot of sense.
Well, the thing is the equation that we're going to come up with. You're right. Maybe we shouldn't have said anything about it until the moment we need it. But I think you're going to see that we need it because aren't you going to the thing you're going to relate here are the side lengths. Is this thing squared plus this thing squared equal this thing squared? And by this thing, I mean these sides.
Yes, it's going to be, yeah. And it's going to be hours. 50, we're not talking about hours. We're thinking minutes and hours are the same. You take the speed of their distance change no matter how far apart they are.
Yeah, there is an observation to make here about that fact. That maybe like all of those distances cancel out, maybe, or something like that equation. Yes.
You should answer.
In this particular,
50 miles per hour.
it is, but and you can justify based on what you just said. What if one of them started here or something though? Would you be able to make the same kind of conclusion? The only I'm just suggesting that happens to work here on this particular problem, what you just said, but let's be careful about like how we say that. Yeah, maybe I'll solve it your way too. I know what you're saying though. Yeah. What do we decide this is? 4 miles and 3 miles? And 5 miles, and again, this is just at one particular moment in time. So, what do we want to call these sides? What do you want to call this length here? I mean, it's a little bit tricky. We'll call it B, I guess. That's fine, because it's the length, it's the amount of distance B has traveled. And this we'll call A, and maybe we'll call that C. It's just not normally how we label triangles in like geometry class, but we'll go with it. Okay. So here we go. What's the relationship between A, B, and C? If you calculated the 3, 4, and then 5 here, you already know that it's A squared plus B squared equals C squared, the Pythagorean theorem. We've already done a problem like that earlier on the top of this PowerPoint today. And we've actually already taken this derivative, so we'll write it down again. With new letters. I think before we took the derivative of x squared plus y squared equals z squared, though, this is quite different because it's A, B, and C. Oh wait, maybe it's not. Okay. And we know dA dt and dB dt. dA dt is 40 miles per hour. dB dt is 30 miles per hour. And we seek dC CDT. So I think we have everything. Again, I don't know if I need to run this through here. But don't we have all 5 pieces of information we need and only one we don't need? This is the only thing we don't have. So I'll let you fill in the blank here. And what did you find DT to be? Yeah. So and then I will highlight a comment Peter was making up here. It seems like, and I'm sure he's not the only one to notice. It seems like, oh, maybe we could have just like shouted out that answer right away.
Please pardon this interruption as I address you about today's event.
I wanted to talk about.
As you know, today students participated in a walkout demonstration in response to last week's election. Participation in this demonstration was voluntary and not condoned, endorsed, or encouraged by our staff. The MCPS regulation JFA-RA, Students' Rights and Responsibilities, states that students have a right to assemble for discussions of issues of importance to them and to demonstrate peacefully. Also in accordance with MCPS policy, students who chose to leave campus will be marked with an unexcused absence unless we receive a note from a parent or guardian excusing the absence within 3 days. This is per MCPS policy. The attendance system will notify parents if their student was marked as unexcused for today. While I strongly encourage student leaders to remain on campus and offered space both within the building and on the grounds for them to demonstrate, they chose to leave campus and walk along Fleet Street to Rockville Town Center. In anticipation of this, we coordinated with Rockville City Police Department to ensure their presence on campus prior to the walkout. With pedestrian safety as our top priority and to oversee the student demonstration, Rockville City Police Department managed traffic along the route and followed students to Rockville Town Center. Unfortunately, the otherwise peaceful protest was marred by a physical altercation between 2 students who had opposing viewpoints. This is unacceptable, and the perpetrator will receive appropriate consequences. As I expressed to all students in a speech this past Friday, while we are all entitled to our own viewpoints and opinions, we must be respectful of opinions that differ from our own, no matter their political perspective. Ultimately, it is a time for us to try to understand each other, rather than seek to be understood. Hateful speech or acts, intimidating language, and bullying for any reason will not be tolerated. I am committed to providing each of our students with a safe and welcoming learning environment. To help us ensure that our school remains welcoming for all, we are asking for help from students. If you see or hear about vandalism, offensive messages, or other forms of harassment, they should immediately be reported to the main office or your administrator. Now is not the time for us to be divided. It is time to put respect and tolerance above all else and help each other heal as a community. Encourage those around you to be respectful of all opinions, regardless of how much they may differ from your own. We are all Rockets, and together we are Richard Montgomery. Good afternoon.
One thing I thought I'd mention here is this is what Peter was trying to point out, that this is just seems like you could just do 30 and 40 and think about those as like the side lengths and then get 50. But I really want to make sure that no matter what you do in math, that you're always like making sense of problems, right? So why does that work? It seems like that does work. But let's see if we can justify that. How do we actually calculate A? Wasn't it 1/10 of dA dt? So do you see a Pythagorean, and same here, dB dt. And we actually didn't know dC dt before we started, so I'll actually put just dC dt there. Do you see a Pythagorean relationship here, just lurking? If you cancel out all the 2's and the 1/10, don't you get that dA dt squared is plus dB dt squared equals dC dt squared? I just want to make sure that like whatever observation you might make is on really firm mathematical footing. So now that being said, now that I've established this firm mathematical footing, can't we just abuse this and like use that all the time? Well, be careful, because these problems come at you in different ways, don't they? Like, what if this guy starts up here and starts going? Well, then suddenly that relationship is gone, right? Or what if they're like traveling at different, I don't know, one's going this way, like in the cop one, right? Or like with a positive and a negative. And some of these things can throw us off. So whatever you do, make sure you're making sense of problems while you solve them, okay? Yeah.
No, it makes sense here because like time just goes the same way, and they grow it like
Yeah.
it's like similar triangles.
It's also like a multiple. It's like similar triangles, and yes, absolutely. So I've kind of formalized that in a way that already makes intuitive sense to a couple of you. But yeah.
We need to formalize it in such a complicated way, and not just say that that's 3t, 5t, 4t, and then just divide out t before the end of the Pythagorean.
Now, how would you know this was? Let's see, 3, 4
Because we
t,
can express c
and then
as a function.
5
We can
t.
express a, b, and c as a function.
I think
of
I
t.
wrote it as 1/10 d c dt. How would you know? Yeah, I have to think about that. But yeah. I mean, I've never written this out ever in my life. I just wrote it there because Peter said it. But all right, I think you just need to dive into these and experience more of them, right? They're fun. I heard someone